All right, I'm going to go through the problems from your assignment, the 9-8 work, page 43, 21, 23, 25, 27, and 29. We'll see how many we get done in this video. I don't want to make this video too long, but we'll see. The very first thing I want to do is just to write down the equations that we're going to be using. It's the ones that we had already written down, hopefully in your notes. The equations were Vx equals Vx0 plus AXT. And then we have x is equal to x0 plus Vx0t times t plus 1/2 axt squared. And then finally we have Vx squared is equal to Vx0 squared plus 2ax times x minus x0. Okay, so these three equations are the ones we're going to be using throughout these problems. And most of it is just figuring out which equation to use based upon what variables we're given. And so I'll kind of go through these problems all together. And if you have any questions, you can always email me. So first thing, number 21 is what we're going to start with here. All right, so a light plane must reach a speed of 30 meters per second for takeoff. How long a runway is needed if the constant acceleration is 3 meters per second squared? So the first thing I always do with these problems is to write down the variables I have and the variables I need to know. So a light plane must reach a speed of 30 meters per second for takeoff. So the final speed reached must be 30 meters per second. So my Vx, assuming it's going in a horizontal direction, is equal to 30 meters per second. Okay. I'm guessing, it doesn't tell you, but I'm assuming that the plane is going to start off with 0 velocity. So we can assume the initial velocity, Vx0, the initial speed it has is 0 meters per second. And then how long a runway is needed. So how long of the runway is a question of distance. Okay, so x would be, it needs to be, that's our question mark. So we're looking for how far must it travel. I'm just going to assume that it's going to start at the 0 point. So my initial position is going to be 0. And then the acceleration given to me is, so in the x direction, is 3 meters per second squared. All right. Now you can see here, if you look at all of our equations and variables, the one that we don't have, we were not given, was t. So we can't use an equation with t in it because we don't know. So if you look at our three equations, the only one that doesn't have t in it is this one right here. Okay, so that third equation is the one we're going to have to use in order to solve this problem. I just want to maybe point out kind of like a picture maybe. So if we have this airplane here, that's going to be my airplane. It's going down the runway, right? It's traveling down the runway. It starts at 0 meters per second, but it needs to get to 30 meters per second. It's accelerating from 0 to 3 at 3 meters per second squared. And we're looking for how far does it need to travel for it to reach that speed in order to go. This initial position is equal to 0, so we're saying that's 0. It starts with 0 meters per second and 0 meters distance, and we're looking for how far does it need to travel. So its final position would be this x point over here. Okay? All right. So usually you do want to draw pictures. I'll make sure to do that in the future as well. It's always helpful to draw pictures to figure out and visualize what's going on. So, like I said, we're going to use that third equation there. Now, something that I'm going to go over again and again is to manipulate the equations first using variables and then plugging in numbers. That's because a lot of AP questions you don't actually, sometimes you don't even need numbers, or they won't even give you numbers, and you'll have to figure it out deriving equations without numbers. So we do want to practice that every single time. It is more appropriate to do it that way. I know some of you would prefer to put in numbers. Maybe almost all of you would prefer to put in numbers first and then do the algebra, but we're going to practice again and again doing the algebra first. So here we go. Let me choose blue. So we start with this equation. Vx squared is equal to Vx0 squared plus 2ax times x minus x naught. All right. So x is going to be our question mark here. So we need to figure out how to put x on one side of the equation by itself. Now, one thing I will let you do is just go ahead and make this 0 right away, because that'll simplify things a lot and allow us to do the problem a little bit more simply. So I'm just going to cross that out right away. That way I don't have to distribute the 2ax. Makes things a little more simple. All right, so the first thing I'm going to do here is I'm going to subtract Vx naught squared, or Vx0 squared, from both sides. So I'm going to subtract that from both sides. What that allows us to do is this cancels with that and gets transferred over to the other side. Okay, just like that. Now I want x by itself, so I've got to move the 2ax by dividing it. So I'm going to divide 2ax. I'm always going to do the opposite of what it is. So if it's multiply, I'm going to divide to get rid of it. So I'm going to divide that from both sides. This will reduce to 1 with that, and so I'm left with only x on that side, which is what I want. All right, now at this point, I can just plug in my numbers to get my final answer here. So I'm just going to flip-flop these because usually I write the variable I want on the left. Let me do it over here. So, oops. So x is going to equal, so Vx we said was 30, so we're going to have 30 meters per second. Now that whole thing is squared, minus Vx0 is 0, so that's nice, that one. 0 squared is going to be 0. And then 2 times 3 meters per second. And that is the acceleration there. Oh, 3 meters per second squared. Now notice the squared there is inside the parentheses because it's a part of the unit. It's not actually, we're not actually squaring the 3, it's just telling you the units for that acceleration there. We are going to square the 30 on top. So I'm going to plug in my calculator and do 30 squared minus 0 is just the same number, so I don't have to worry about that, divided by parentheses 2 times 3. Or divide by 6, if you will. So the final answer I got was 150 meters. All right, and that is the distance that the plane needs to travel in order to reach that speed. All right, now let's go on to the next problem here, which is problem number 23. Problem number 23 says, a car slows down from a speed of 25 meters per second to rest in 5 seconds. How far did it travel in that time? So, let me draw the picture first here. So we have a car. By the way, I have amazing drawing skills, obviously. So it's moving at, it says 25 meters per second. Starts at some point here, x0. It's going to slow down for 5 seconds and eventually come to a rest. So it's going to be moving at 0 meters per second. Okay, let me just get rid of that. So 0 meters per second. And it's asking how far did it travel in that time. So we're worried about this here, the distance from x to x0, x minus x0. Now, I'm just going to make this 0 right away, so really I'm looking for x in this case. So let me go ahead and write down the variables I know. I know my initial speed, vx0, is 25 meters per second. My final velocity, vx, I want to be 0 meters per second, so it comes to a stop. I know the time is 5 seconds, and I know the initial position, I'm going to say 0 meters, and my final position is going to be my question mark. How far did it travel? All right, so now the car is slowing down here, so it has a negative acceleration, but I'm not given acceleration at all. So if I look back at my equations, all of them have acceleration in them, but we don't know the acceleration. So what we need to do first is to find the acceleration. So, okay, well, here's the thing. We could find the acceleration, then plug it back in ultimately to find the time. You could also think about the fact that what is the definition of velocity? So velocity, you know what? Never mind. That's where I want to just stick to the equations that were given on our equation sheet. Okay, so we have to find the acceleration first and then plug it in to find the distance. The one that looks easiest to me to find acceleration is that first equation. So we have Vx is equal to Vx0 plus Ax times t. So I'm just going to find my acceleration first. So first thing I need to do here is subtract the Vx0 from both sides so that those reduce out. And then I have Vx minus Vx0 is equal to Axt. So I'm going to divide by t so that those reduce out. And I have, I'm just going to flip-flop them. Ax is equal to Vx minus Vx0 over t. All right, so now I'm going to plug in my numbers. I know Vx is 0 meters per second. Subtract Vx naught, which is 25 meters per second. Then divide by my time of 5 seconds. So what I actually get here is Ax is equal to negative 25 divided by 5. So it's actually negative 5 meters per second squared. That's because if you look here, the meters per second divided by seconds, meters per second is meters per second squared, which is perfect because that's the unit that we expect for acceleration. All right, so now we're just going to plug that into any of the equations. Well, the second or third equation to find a distance. The second equation, is the easiest one to use because it has x equals already, and we don't have to do any algebra that way. So let me just use a different color here. So we have x is equal to x naught plus Vx0 t plus 1/2 Ax t squared. So all I'm just going to do is plug in my numbers because x is already what I'm looking for here. So we have 0 meters plus 25 meters per second times 5 seconds for time, plus 1/2, we have negative 5 meters per second squared times a time of 5 seconds squared. So notice the acceleration is negative, which in this case means it's moving to the right but slowing down. Okay, so it's moving in the positive direction, but it's slowing down. All right, I'm just going to plug in my numbers into my calculator here. I usually do it from the right to left, just because that squared is always in there and kind of messes with me. So 5 squared times negative 5 times 1/2, and I got negative 62.5. I'm going to add 25 times 5 in parentheses, and I got 62.5 plus 0, which is 62.5 meters is my final answer there. All right, so you can see for this problem, ultimately I had to solve for acceleration first because acceleration is in each one of those equations. So I had to find an equation without x in it, which was the first equation, to find my acceleration. Then I used to use that acceleration in the second equation to find the distance, which is ultimately what the problem was asking for. So this is kind of a two-step problem, a little bit more difficult. That's why there's a little Roman numeral 2 next to it, saying that it's a little bit more difficult. And as you go to Roman numeral 3, it's going to get even more difficult here. So I'm actually going to stop this video here and do the rest of the problems on a separate video just to make sure that everything's working correctly and I don't have to redo this video. So I just want to check that out, and I'll make that second video.